Dear students, welcome to the today's chemistry class. So in the last class we discussed 7 fundamental physical quantities or 7 basic physical quantities and their SI units. So in this class let us discuss some physics words like mass and weight. Mass and weight. ಸೊ ನೋಡೋದಕ್ಕೆ ಮಾಸ್ ಅಂಡ್ ವೇಟ್ ಅನ್ನೋ ವರ್ಡ್ಸ್ ಒಂದೇ ಥರನೇ ಇದೆ, ಬಟ್ ದೇ ಆರ್ ಡಿಫರೆಂಟ್. ಅದರ ಮೀನಿಂಗೇ ಬೇರೆ. ದ ಮೀನಿಂಗ್ ಆಫ್ ಮಾಸ್ ಅಂಡ್ ದ ಮೀನಿಂಗ್ ಆಫ್ ವೇಟ್ ಆರ್ ಡಿಫರೆಂಟ್. ದೆನ್ ವಾಟ್ ಈಸ್ ಮಾಸ್? ವಾಟ್ ಈಸ್ ದ ಮಾಸ್ ಆಫ್ ದಿ ಸಬ್ಸ್ಟೆನ್ಸ್ ಅಂಡ್ ವಾಟ್ ಈಸ್ ದಿ ವೇಟ್ ಆಫ್ ದಿ ಸಬ್ಸ್ಟೆನ್ಸ್? ಹಾಗಾದರೆ ಡೆಫಿನೇಷನ್ ಏನಿದೆ? What is the definition of mass of the substance and what is the definition of weight of the substance? Let us discuss. And also, what are the differences between the words mass and weight? Let us discuss mass. Mass is nothing but the amount of matter present in the substance. The amount of matter present in the substance means, say you take, this is the matter. So this is the substance. Hagadre what is the substance? Substance anta tagondre what is the amount of matter present in the substance? How many atoms are present? How many molecules are present in the substance? How many ions are present in the substance? The total, the sum of all those atoms and molecules and ions present in this substance gives mass of this duster, that is substance. Say you take, this is piece of chalk, this is one substance. So here in this piece of chalk particles are present, that is atoms. The sum of all the atoms present in this piece of chalk is called as amount of so particles or atoms present in this piece of chalk. So now the mass of this piece of chalk is, say, take 5 gram or 10 gram. 10 gram represents, or 10 gram is due to the presence of so all the atoms or molecules are present in this piece of chalk. So mass is nothing but totally the amount of matter present in the substance. Present in the substance. The amount of matter present in the substance is called as mass of the substance. ಯಾವುದೇ ಒಂದು ನಾವು ಸಬ್ಸ್ಟೆನ್ಸ್ ತಗೊಂಡಾಗ ಅದರಲ್ಲಿ ಎಷ್ಟು ಆಟಮ್ಸ್ ಇದೆ, ಅದರಲ್ಲಿ ಎಷ್ಟು ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಇದೆ, ಅದರಲ್ಲಿ ಎಷ್ಟು ಅಯಾನ್ಸ್ ಇದೆ, ಅವುಗಳು ಎಲ್ಲವನ್ನೂ ಸೇರಿದ್ರೆ ಮಾಸ್ ಆಫ್ ದಿ ಸಬ್ಸ್ಟೆನ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ನೆಕ್ಸ್ಟ್ ಕಮ್ ಟು ದಿ ವೇಟ್. Weight of the substance is nothing but the force exerted by gravity on an object. The force exerted by gravity on an object is called as weight of the substance. ಇದೇ ಸಬ್ಸ್ಟೆನ್ಸ್ ತಗೊಂಡೆ ಈಗ ಮಾಸ್ ಆಫ್ ದ ಸಬ್ಸ್ಟೆನ್ಸ್ ಅಂತಂದ್ರೆ ಅಮೌಂಟ್ ಆಫ್ ಮ್ಯಾಟರ್, ಅಮೌಂಟ್ ಆಫ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಪ್ರೆಸೆಂಟ್ ಇನ್ ದಿಸ್ ಸಬ್ಸ್ಟೆನ್ಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಮಾಸ್ ಆಫ್ ದಿ ಸಬ್ಸ್ಟೆನ್ಸ್. ಹಾಗಾದ್ರೆ ಇದೇ ಸಬ್ಸ್ಟೆನ್ಸ್ ಮೇಲೆ ಎಷ್ಟು ಗ್ರಾವಿಟೇಷನಲ್ ಫೋರ್ಸ್ ಆಕ್ಟ್ ಆಗ್ತಾ ಇದೆ, ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ weight of the substance, because gravitational force is different at different places. So that the force exerted on the object due to gravity is called as weight of the substance. So mass and weight of the substance are different because mass of the substance is always constant at all the places. ನಾವು ಯಾವುದೇ ಒಂದು ಸಬ್ಸ್ಟೆನ್ಸ್ ತಗೊಂಡು ಅದರ ಮಾಸ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡಿದಾಗ ಅದರ ಮಾಸ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿರುತ್ತೆ. Say you take mass of this substance measured on the earth is considered as say 50 gram. ಇದೇ ಒಂದು ಡಸ್ಟರ್, ಇದೇ ಒಂದು ಸಬ್ಸ್ಟೆನ್ಸ್ 50 ಗ್ರಾಮ್ ಇರ್ತಕ್ಕಂಥ ಒಂದು ಸಬ್ಸ್ಟೆನ್ಸ್ ತಗೊಂಡು ನಾವು ಇನ್ನೊಂದು ಬೇರೆ ಪ್ಲಾನೆಟ್ ಹೋದ್ರೆ ಅಲ್ಲಿ ಗ್ರಾವಿಟೇಷನಲ್ ಫೋರ್ಸ್ ಬೇರೆ ಇರುತ್ತೆ, ಅದು ಮಾಸ್ ಆಫ್ ದಿ ಸಬ್ಸ್ಟೆನ್ಸ್ ಮಾತ್ರ ಅಷ್ಟೇ ಇರುತ್ತೆ. weight changes from place to place because due to the change in the gravitational force. ಗ್ರಾವಿಟೇಷನಲ್ ಫೋರ್ಸ್ ಅನ್ನೋದು ಒಂದು ಪ್ಲೇಸಿಂದ ಇನ್ನೊಂದು ಪ್ಲೇಸ್ಗೆ ಚೇಂಜ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಅದರಿಂದ ವೆಯ್ಟ್ ಆಫ್ ದಿ ಸಬ್ಸ್ಟೆನ್ಸ್ ಚೇಂಜ್ ಆಗ್ಬೋದೇ ಹೊರತು ಮಾಸ್ ಆಫ್ ದಿ ಸಬ್ಸ್ಟೆನ್ಸ್ ಅಷ್ಟೇ ಇರುತ್ತೆ. ಈ ಡಸ್ಟರ್ನ ನಾವು ಇನ್ನೊಂದು ಪ್ಲಾನೆಟ್ ತಗೊಂಡೋದ್ರೆ ಅಲ್ಲೂ ಡಸ್ಟರೇ, ಇಲ್ಲಿ ಎಷ್ಟು ಮಾಸ್ ಇತ್ತು ಅಲ್ಲೂ ಕೂಡ ಅಷ್ಟೇ ಮಾಸ್ ಇರುತ್ತೆ ಹೊರತು ವೆಯ್ಟ್ ಸೇಮ್ ಇರಲ್ಲ. ಬಿಕಾಸ್ ಗ್ರಾವಿಟೇಷನಲ್ ಫೋರ್ಸ್ ಈಸ್ ಡಿಫರೆಂಟ್ ಫ್ರಮ್ ಪ್ಲೇಸ್ ಟು ಪ್ಲೇಸ್. So that is second difference between mass and weight is mass of the substance. Mass of the substance is remains same. Mass of the substance is remains same in all the places. ನೀವು ಯಾವುದೇ ಒಂದು ಸಬ್ಸ್ಟೆನ್ಸ್ನ ಮಾಸ್ನ ಮೆಜರ್ ಮಾಡಿದಾಗ ಇದಕ್ಕೆ ಎಲ್ಲ ಪ್ಲೇಸಸ್ಸಲ್ಲೂ ಸೊ ಮಾಸ್ ಆಫ್ ದಟ್ ಸಬ್ಸ್ಟೆನ್ಸ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಸೇಮ್ ಆಗಿರುತ್ತೆ. ವೆಯ್ಟ್ ಕಪ್ಪದೆ ವೆಯ್ಟ್ ಆಫ್ ದಿ ಸಬ್ಸ್ಟೆನ್ಸ್ ವೆಯ್ಟ್ ಆಫ್ ದಿ ಸಬ್ಸ್ಟೆನ್ಸ್ varies place to place. And the weight of the substance varies from one place to another place. This is due to the change in the gravitational force. Weight of the substance varies from place to place due to change in the gravitational force. Due to change in the gravitational force. And next, once again, mass of the substance as SI unit kilogram. So mass of the substance is measured in terms of the SI unit called as kilogram. Third difference between mass and weight is SI unit. SI unit of mass is kilogram. That is kg. The SI unit of weight of the substance is called as Newton. SI unit of weight is Newton. So that is a capital N. So once again, in the laboratory, the chemistry laboratory, mass of the substance is accurately determined by using analytical balance. So in the laboratory, mass of the substance is accurately determined by using analytical balance. So in the practical classes, we can clearly explain the analytical balance, how to measure the mass of some chemicals using that analytical balance. So totally, so these are the differences between mass and weight of this substance. The amount of matter present in the substance is called as mass. Mass of the substance is remains same in all the places. The SI unit of mass is kilogram. Mass of the substance is accurately measured by using analytical balance. Weight of the substance is nothing but the gravity, the force exerted by the gravity on an object is called as weight. The SI unit of weight is Newton. Weight of the substance varies from one place to the another place due to the change in gravitational force. Next come to the another physical term. So that is volume. Another physical term. So volume. So it is one of the derived unit. So it is derived from the basic physical quantity. So that is length. So here volume is nothing but the amount of space occupied by the substance. ಯಾವುದೇ ಒಂದು ಸಬ್ಸ್ಟೆನ್ಸ್ ಎಷ್ಟು ಸ್ಪೇಸ್ನ ಆಕ್ಯುಪೈ ಮಾಡಿಕೊಂಡಿದೆ, ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ವಾಲ್ಯೂಮ್. The amount of space, the amount of space occupied by the substance. The amount of space occupied by the substance is called as volume. The SI unit of volume is SI unit. Volume as SI unit called as cubic meter. Cubic meter or meter cube. The SI unit of volume is called as cubic meter. ಯಾಕಂದ್ರೆ volume can be represented by or defined by length or cube. The SI unit of length is meter. So that meter cube. SI unit of volume is meter cube. So that is volume is called length cube. So length, SI unit of length is meter. So that meter cube. So cubic meter. So that cubic meter is the SI unit of volume. So once again, in addition to the SI unit of volume, cubic meter, in the chemistry laboratory in day-to-day life, we can use other common units to measure the volume of the liquids or solutions. SI unit of volume is cubic meter. But in addition to the SI unit of volume cubic meter, in the day-to-day life in the chemistry laboratory to measure the volumes of liquids and solutions, we can also use some general or common units called as liters. Liter. So 1 liter is nothing but 1000 ml. Ml is nothing but milliliter. Or 1 liter is equals to 1000 cm cubic centimeter. These are all smaller units because in the laboratory you can measure 1 ml, 2 ml, 3 ml, 1 liter, 2 liter, 3 liter, etc. So that we cannot use 1 cubic meter, 2 cubic meter, 3 cubic meter in the laboratory while measuring the liquids. So even though cubic meter is the SI unit of volume. And once again, so 1 liter is also equal to 1 dm cube. So 1000 cm cube, 1000 cm cube, 1000 ml, 1 dm cube. So decimeter cube, dm cube, milliliter, cubic centimeter. So these are the common units used in the laboratory to measure the volumes of solutions and liquids. So in the laboratory to measure the volumes of solutions and liquids, we can use certain instruments. We can use certain instruments. So that is instruments or operators. We can also call as operators. Operators used to measure. Operators used to measure volumes in volumes of liquids or solutions in laboratory. Certain operators can be used in the chemistry laboratory to measure the volumes of liquids or solutions. Those are graduated cylinder, graduated cylinder. So it will be looks like this, graduated cylinder. Using graduated cylinder, so volume of liquids or solutions can be measured. So that's a graduated cylinder. Second one, pipette. Pipette can be used to measure generally the concentrations, high concentrated acids or bases. Pipette. So it looks like this. So it will be looks like this. So 25 ml pipette or 10 ml pipette. Pipette can be used to pipette out or to measure concentrated acids. That is, a pipette can be used to measure dilute acids, because pipette can be handled through the mouth, so that it can be used only to measure dilute bases or acids or salt solutions. So another operators, third type of operators that can be used to measure the volume of solutions or liquids is called as burette. So burette it looks like this. Burette can be used in the titration experiment. So it will be looks like this. 50 ml burette. So in addition to this, conical flasks, beakers can be used for the measurement of volumes of liquids and solutions. So we have different types of operators for the measurement of volumes of liquids and solutions. So the first one is graduated cylinder. Second one is pipette. Pipette can be used only for measuring the concentration of or only for measuring the volume of the dilute solutions. Dilute solutions, that is dilute acids, dilute bases, dilute salt solutions can be pipetted out through the mouth, so that pipette cannot be used for measuring the concentrated acids or concentrated bases. And burette can also be used for the measurement of volume of the solutions or liquids.